right, folks, what we're going to do in this particular lesson is I'm going to introduce to you the idea of limits. Okay, in calculus is basically broken up into three main topics: limits, derivatives, and integration. Okay, so in order to understand derivatives and integration, you have to first understand a concept called limits. Okay, now sometimes limits can be a little frustrating for students, but I assure you they are actually very easy once you get the hang of them. In fact, in many ways, you're going to say, well, why do we have to do limits this way when you can do them this way? It's so easy. There are technical concepts associated with limits, so we have to do them exactly how I show you. Okay? All right, so this is a typical, well, this actually isn't very typical. Limit problems in calculus are usually fractions. They're usually rational functions, but we'll get to that later. But what you're looking at here is what we call a limit problem. And when you see a limit problem, there's a certain way that you have to say it in your mind or say it out loud. Okay, so the way that we would read this limit problem would go like this. And by the way, we know it's a limit problem because it has this little LIM. LIM stands for limit, or what is the limit, okay? So the equal sign over here is basically asking the question, what is, right? So if you see like 2 plus 5 equals, and a little line, it's saying, what is 2 plus 5, right? Okay, so it's asking, what is the limit of 2x squared minus 3x plus 7 as x approaches 5. And probably the most confusing part of this entire thing is this arrow right here, okay, this x arrow 5. The way we're going to say that is x approaches 5, or as x is approaching 5. We're going to talk about what approaching means in just a couple minutes, okay? All right, so let's look at this one. This is another limit problem, but instead of specifying the analytic expression of the function, we're just going to say f of x, okay? So this is going to say, what is the limit of the function f of x as x approaches negative 4, okay? Now, in a limit problem, the x is an input variable, just like in most of the math that you have done in pre-calculus and in Algebra 2, x is typically an input variable. You are plugging a number in to the function to get an output variable. Okay, well, what is an output value? What is the output value? Well, the output value is typically represented by either the function f of x or the letter y. If you see 2x squared minus 3x plus 7, usually what that means is that y is equal to 2x squared minus 3x plus 7. And so this function in here is just a representative of the output function, or the output variable, or the output value, okay? So here's the input, here's the output. Very similar to what you've been dealing with so far with inputs and outputs, but instead of dealing with the actual value of the output, and instead of calling x 5, instead of saying x is equal to 5, see, in a pre-calculus class, you would say, well, when x is equal to 5, well, we're going to change this now. Instead of saying x is equal to 5, we're replacing the equal sign with an arrow, and we're saying that x is approaching 5, okay? So let's talk about what the word approaching means. All right, so let's say, for the sake of argument, that y is equal to x squared plus 6. Okay, this is just a simple function, probably something that you've seen for a few years, ever since you were in either analytic geometry or algebra 1 or something like that. And then now we have a limit. So now this is algebra, this is calculus. When you do a limit, it becomes calculus, okay? So we're saying, what is the limit of x squared plus 6 as x approaches 5, okay? Well, what we could do is we could replace x squared plus 6 with the letter y, right? Because y is equal to x squared plus 6. So we can just put a y right here. And so what we're really saying is, what is the limit what is the limit of y as x approaches 5? Well, what that basically means, what it's basically asking is this, is as x approaches 5, what does y approach? What is y approaching? Okay? What output value is y approaching as the input value is approaching a value of 5? Well, you may be a little confused about that question because you may not know what the word approaches means. So what I want to do is let's talk about what does approaches mean in a limit. So what does approaches mean? Well, in math, for a variable to approach a particular number, it means to get incrementally closer and closer and closer to that number without actually touching that number. Okay, so what I have here is an example. I have three x values. Let's say x sub 1, our first x value is 4.9. Our second x value is 4.99, and our third x value is 4.999. So here's what we have. 4.99 is a little bit larger than 4.9. It's incrementally larger. And 4.999 is a little bit incrementally larger than 4.99. Okay? So what's happening here is x is becoming incrementally larger with each subsequent x value. And what I want to know is what number is x getting closer to? So as x gets incrementally larger and larger and larger, what value is x approaching? Okay, well, it looks like, what's 4.999 really close to? It looks like it's getting closer and closer to 5. So if we go 4.9, 4.99, 4.999, what do you think the next number is going to be? It's going to be 5. We're getting closer and closer to 5 without actually touching 5. Okay, let's do a couple more examples just like that. Okay, let's try this one now. Now instead of an x value, we're saying it's a y value, which is just fine. Like I said before, x is incrementally getting closer to a number. Y is also incrementally getting closer to a number. So let's see what number y is getting incrementally closer to. Well, our first y value is 30.01. Our second y value is 30.901. So what happened to this? This number, this 30, got a little bit larger, right? How much did it get larger by? Well, it went from 30.01 to 30.901. So let's do 30.901 minus 30.01, and we get 0.891. It got larger by 0.891. Okay, it went up by 0.891. All right, now, when it went from y2 to y3, it went from 30.901 to 30.9901. So let's see how much it got larger by. 30.9901 minus 30.901, and it got larger by 0.0891. So here, it went up by 0.0891. This 0.891 is almost 1, but 0.0891 is almost 0.1. So this increment is a larger increment than this. So the increments are actually getting smaller. Well, what number does this look like it's very close to? We're obviously increasing, so it's going to be a number that is larger than these numbers. What's the next number that you think? What are we getting closer to? Well, 30.99 is right next to 31. And so it's very likely that what we're looking at here is that y is approaching 31. Okay? Let's try another example. All right, so let's try this one. So now what we have is instead of the letter x or the letter y, we're using f of x. So, and that's just another way of saying y, right? You know, f of x is a function notation. Y is also an output. F of x is an output, right? But in this case, it's f of x1 Here it's f of x2, and here it's f of x3. So apparently x is getting incrementally closer to a number, and we want to know, well, what number is f of x getting incrementally closer to? And in the last example, I don't want you to think that every time your increments are going to get smaller and smaller and smaller and smaller every time. In this one, I made a constant increment. First, we're at 3.003, then 3.002, then 3.001. Now, our numbers are obviously getting smaller here, right? So 3.003 is larger than 3.002, and that's larger than 3.001. So the number's getting smaller. Well, what should the next number probably be? Well, it looks like we're getting closer and closer to 3, right? If we go down by one more 0.001, each time we're going down by 0.001, right? If we go down by 0.001 one more time, we're going to be at 3. And in this particular case, f of x is approaching 3. Now, the last two examples we did, the numbers were getting incrementally larger. And in this example, the numbers are getting incrementally smaller, and that's okay, because we can approach a number from the smaller number side or from the larger number side. We're going to get to that in a couple minutes. The idea that you can approach any value from both sides. The higher side, the higher number side, can get smaller and approach the number, or the lower number side can get larger and approach the number. Okay? Let's try just one or two more examples. Okay, now look at this example. We're back to using y here. Okay, so the first y value is 3.59. The second y value is 3.599. It's a little bit larger than 3.59. And then the third one is 3.5999, which is a little bit incrementally larger than 3.599. What do you think, what number do you think we're getting close to? Now, you might think that because the numbers are at 3 point something and we're getting larger, that we're getting closer to 4. But we are not getting closer to 4. The key here, notice that this 5 is not changing. It's 59, 599, then 5999, right? It looks to me, ignore the 3 just for a second, and if we have 0.59, then 0.599, then 0.5999, it looks to me like we're getting closer to 0.6, right? And so since the 3 doesn't seem like, it's not like we're getting to 3.9999, it's 3.5999, okay? And it looks to me that what y is approaching in this particular situation is 3.6. Now, it does take a little bit of almost like being a detective to try and figure out what you're getting closer to. And some people are better at noticing what it's getting closer to than other people, so it can be a little difficult sometimes when you're only dealing with numbers. Now, I'm going to teach you how to do limits without using the multiple numbers. There are other ways, analytical ways of doing it, where you can just use algebraic techniques and get the answer without having to have these 3 numbers in a row and see what they're getting to, okay? All right, so what's the difference between a one-sided limit and a two-sided limit? Well, you probably have no idea right now because this is the first time you've ever even heard of limits, maybe, okay? Well, let's look at this. Let's do a couple of these. These are separate circumstances. In this one, we have the first x value is 4.9, then 4.99, then 4.999. We already did this one. We know that in this situation, x is approaching 5, right? Well, let's try over here. What if we started out with the first x value is 5.1, then the next x value is 5.01, which is smaller, incrementally smaller than 5.1, right? And our third one is 5.001, which is even smaller than 5.01. So what's happening is these values, these x values, are getting incrementally smaller, but what are they getting closer to? Incrementally, what number are these x values approaching? Well, they're approaching 5, okay? They're getting smaller and smaller, approaching 5. Well, you may say, well, hey, Mr. Ryan, you have two of the same situation here. Here, you have x approaching 5, And here you also have x approaching 5, but they're very different circumstances. I know that's because on this one, x is approaching 5 from the smaller number side, and on this one, x is approaching 5 from the larger number side. That's because every value along the number line, okay, here's 5, every value has two sides. We can approach 5, let's say 4 is over here, and let's say 6 is over here. We can get closer to 5 by starting at 4 and approaching from the left, or we can start at 6 and go backwards and approach 5 from the right. So we can approach 5 from what we call the left side, which is the negative side, right? So if you have a coordinate plane, here's the left side of the coordinate plane. All the x values are negative on the left side, and all the x values are positive on the right side, right? And so to approach a number from smaller numbers means to approach from the left side or the negative side, and to approach 5 from a larger set of numbers, that means you're going backwards, and you're approaching 5 from the right or from the positive side, okay? Or all the values that are larger than 5, whereas on the left, it's all the numbers that are smaller than 5. And so what we do here is we put notation on the number. In this case, x is approaching 5, and we're going to put a little superscript like an exponent. We're going to put a negative there. X is approaching 5 from the smaller number side. That means from the left. Whereas over here, x is approaching 5 from the larger number side. We'll put a little superscript positive there. This is saying x is approaching 5 from the positive side, from the larger number side. When you write an x approaches a number, and if you put either a minus or a plus, you're telling us only approach from one side. That is called a one-sided limit. So this is a one-sided limit, or this is notation from a one-sided limit, and this is notation from a one-sided limit. If you do not see the notation, if you just see x approaches 5 with no notation up here, it is a two-sided limit, and what this means is to approach 5 from both sides. It's telling you, hey, let's approach 5 from the left and from the right. We'll squeeze in on 5 from both sides, and we'll see what the output value is approaching, okay? I'm now going to give you a couple examples of limits that are one-sided and a limit that is two-sided. All right, so here's 3 examples of limits, and each one is different in terms of sides, okay? They all say limit as x approaches 6 of x squared minus 3, okay? But notice that this one has the superscript of a negative, this one has the superscript of a positive, and this one doesn't have a superscript at all. Therefore, this is a one-sided limit, this is also a one-sided limit, and this one right here is a two-sided limit, okay? This is a two-sided limit. So this implies that they want you to identify what this function, it's supposed to be an x squared, what this function is approaching from both the left side and the right side, okay? So as x is approaching 6 from the left side, what is the output approaching? As x is approaching 6 from the right side, what is the output approaching? That's what this is basically asking. But up here, this one-sided limit, because it has the minus here, this is a left-sided limit. And this one, because it has a plus, this one is a right-sided limit, okay? And that is the basic distinction in looking at limits. What is the difference between a left-sided, right-sided, and a two-sided? And so what we're doing today is primarily focused on one-sided limits. And in the day 2 lessons, the next thing we're going to learn about limits, we're going to do two-sided limits. All right, so in the previous examples, I gave you three numbers, three x values, and you had to identify what number x was approaching, right? Well, now what we're going to do is we're going to switch it the other way. What we're going to do is, what I want you to do is make a list of three values for every one of these x approaches that I give you. So here, I want you to give three values of x approaching 9 from the left, and then three values for x approaching 9 from the right. Okay, so pause the video and try to do that. All right, so hopefully you did something like this. Now, there are several ways of answering this. In fact, there's an infinite number of ways of answering this. But we know that whatever happens, these numbers, these three numbers, have to be smaller than 9. Okay, so let's say 8, right? 8 point something. So they're all going to be 8 point something, because they all have to be incrementally smaller than 9, okay? And as we go from x1 to x2 to x3, these numbers have to get larger, larger, and larger. And one very easy way to do that is to make this one 8.9, this one 8.99, and this one 8.999, okay? So we're getting incrementally closer to 9 from the smaller number side. We can do the exact same thing down here, but now we have to get closer to 9, but all the numbers have to be larger than 9. Well, the best way to do that is to make all three of them 9 point something. Because if they're all 9 point something, then they're going to be larger than 9, right? Well, the x3, we want this one to be the closest one to 9. So this is going to be the smallest number, this is going to be the next smallest number, and this one is going to be the largest number. Now, for me, the best way to do that is to do 9.1, then 9.01, and then 9.001, okay? Now, I'm going to show you another way of doing these exact same two questions, okay? The three values from each of the questions. We're still going to leave these as 8 point something, and we're still going to leave these as 9 point something. But another way to get incrementally closer is you can get incrementally closer in the same jumps, all right? So what we can do here is we can make this one 8.997, then this one 8.998. That's larger than this, and it's closer to 9, right? And 8.999. And as you can see, as we go from 8.997, 8.998, 8.999, we are getting closer and closer to 9 from the left side. Now over here, we want this to be the largest number, and we want to get progressively smaller in increments. So what we can do is we can make this 9.003, then 9.002, then 9.001, and then of course the next number would be 9, right? So we're getting incrementally closer to 9 with numbers that are larger than 9, okay? Let's just do a couple more examples of these. All right, so here's another example that you can try, but these are a little harder. It's not really harder, it's just that some people get confused when we use negative numbers, okay? Because on the negative side of the x-axis, or of the y-axis, okay, so where all the x's are negative, the smaller values look like they're larger than the number you're approaching. Okay, here's what I mean. This says as x approaches -2 from the left. By the way, if you want to just try this, you can just pause the video and do it on your own. Otherwise, you can now follow along with me. So x approaches -2 from the left. Remember, from the left means numbers that are smaller than -2. Well, here's what I want to remind you. All of the numbers that are smaller than -2 are, like, for example, -3, -4, -5, -6, okay? All of these numbers are smaller than -2. You might say, hey, Mr. Ryan, I don't know if you know this, but it sounds like you're kind of dumb there, because 3, 4, and 5, and 6 are all larger than 2. Yes, 3 is larger than 2, but -3 is not larger than -2. -3 is actually a smaller number because it is farther to the left on the x-axis, okay? So all of these numbers are smaller. So you may think that you're going to put like -1.9 here, but actually -1.9 is larger than -2. So this -1.9 should actually be down here in the coming from the right. Negative 1.9 is on the right side, the positive side of negative 2 on the x-axis. Okay? All right, so here these are all gonna be negative 2 point something, because these are negative 2 point something is smaller than negative 2, and we want to get closer and closer to negative 2. So this one is going to be, let's say, 0.001. Then this one can be 0.1, and this one can be 1. So we got negative 2.1, then negative 2.01. That's a little closer to negative 2. Then negative 2.001, also a little bit closer to negative 2. Now on the larger side of negative 2, here's where we're going to have our negative 1.9. Okay, so negative 1 point, negative 1 point, and we can have 9, then 9, 9, and then 9, 9, 9. See, negative 1.999 is right next to negative 2. A little farther away, but still close, is negative 1.99, and still close, but a little bit farther away, is negative 1.9. And so as we go from x1 to x2 to x3, these numbers are getting closer and closer. They're approaching negative 2, okay? Let's do one more example. All right, so then here's another one that can be a little confusing when we're dealing with 0, okay? So here we want 3 values where x is approaching 0 from the left, and then 3 values where x is approaching 0 from the right, okay? So what you have to do is you have to think about, well, what numbers are right next to 0? And you might think, well, from the left, we know that negative 1 is to the left of 0. That's true, but that's a little far away from 0 to be approaching 0, okay? To approach 0, here's what I recommend you do. If you're not sure, grab a calculator and do 0 minus 0.001. So I'm going to go 0 minus, because we want them to be less than, right? So we're going to minus 0.001, and I get negative 0.001. So that's right next to 0, is negative 0.001. And that means a little farther away is negative 0.01, and then negative 0.1. So if we were to start here, the first one is negative 0.1, then negative 0.01, then negative 0.001. We're getting closer and closer to 0 from the left side. Now on the right side, let's add 0.001. So we'll go 0 plus 0.001, and we get 0.001. Okay, so that's really close to 0, is 0.001. A little farther away would be 0.01, and a little farther away would be 0.1. You could also do 0.001, 0.002, and 0.003. And here you can do negative 0.001, negative 0.002, and negative 0.003. That would work too. But in this case here, you can see as we go 0.1, then 0.01, then 0.001, we are getting incrementally closer and closer to 0 from the positive side. Okay? All right, well, that's our introduction to limits, the basic idea of limits. And what we're now going to do is the next segment, next couple segments are going to be different ways that you can identify the limit of a function using different techniques, but we're only doing one-sided limits in these segments.